I think we're already very effective in that regard and can implement a lot in a short amount of time. And I think that's really the Zimmermann DNA, you could say. Hi, I'm Andreas Renninger and I work here at Zimmermann in application engineering. I'm the team leader of a small team. We're responsible for making sure the machines arrive at the customer's site in proper condition and that the customer can work with them satisfactorily. There are also projects where we're involved in sales right from the very beginning. That means we advise the customer or come up with an idea of how we can manufacture this component. Then we prepare a proposal, a presentation, and say, hey customer, look, we could manufacture your specific component like this. And in the end, the customer orders the machine. It's actually a really great job to be part of that process and to be able to feel jointly responsible. Here we are sitting inside a dedicated plastic milling machine which is used to manufacture large aircraft parts from plastic or carbon fiber. Here it's all about dynamics and precision in what is being milled, as well as dust extraction. The concept here is really big and also costs a lot of money. We have floor ducts installed. That means over the 13 meters of the machine, there are several ducts on the left and right, and depending on how the machine moves along the x-axis, the ducts open and close automatically so that wherever the milling head is positioned, the greatest suction power is generated. This is basically the head extraction, the bell, which can move up and down and which really tries to extract the dust directly at the tool. Because we really travel a lot around the world and see things at other customers' sites, you often think, wow, they do amazing things, they really get it. Or how does it even work that they're able to manufacture that? That's actually the great thing, that we travel all over the world and get to see the processes up close, how the parts are made and how it all works. So I was just recently back in Canada, in Vancouver, after 4 years at the machine that I helped install or set up 4 years ago. The customer is still satisfied to this day. It is definitely the case that these centrally guided gantries nowadays deliver so much more accuracy, bring more dynamics, and provide more stability, which the old conventional machines where the beam was mounted on the y-axis and the friction movement up and down the z-axis would heat up and drift downward. Normally this would happen in the x direction, but that's no longer the case here. We run a finishing program on the machine for 60 hours. It goes up and down, runs for 60 hours, and then you shut the machine down overnight. The next morning you come back and it's standing exactly in the same spot. And that's really the crucial point we've achieved. FC40 with 3 different spindle changes, the large VH60 head installed, and so on. So really it can finish aluminum at full speed, but it can also machine titanium. With a really powerful spindle inside, and I have to say, for me, that's a machine with real power. At the moment, the user still has to know a lot manually and also have in-depth knowledge, such as how the component will be milled in order to tell the software, with this strategy and that tool, proceed in this or that way. I believe that AI will bring a lot of relief in this area. Well, here at Precision, for me, this is already our latest generation of machines. We now have such extreme precision and thermal stability that we can mill and finish for 60 hours straight. We are one of the few machine builders in the region who have a lot of work, and of course that is very motivating. So when we look at it, we have these new machines, these new models, and everything is running really well and smoothly. The customers are satisfied, and of course we are successful. That's why I fully contribute my part and my employees do the same.